Take a slow breath in and gently let it go. Tonight, we're not rushing anywhere. There's no deadline in space. No ticking clock you need to follow. Just the quiet, steady expansion of the universe itself. In this calm journey, we're going to explore a simple but profound question. Are we living in the middle of the universe's story or somewhere near its end? To answer that, we'll travel across the entire cosmic timeline, from the very first fraction of a second after the Big Bang, through the birth of stars and galaxies, to the unimaginable future that stretches trillions upon trillions of years ahead. Before we begin, if you enjoy calm space documentaries like this, take a moment to gently like the video and subscribe to the channel. It helps support more peaceful journeys through the cosmos. Now let's go back, all the way back. About 13.8 billion years ago, the universe as we know it began. Not as an explosion in space, but as the sudden expansion of space itself. The Big Bang wasn't a fireball erupting into emptiness. There was no empty room waiting. Space, time, energy, all of it emerged together. In the very beginning, the universe was unimaginably hot and dense. Smaller than an atom, yet containing all the energy that would one day become galaxies, stars, planets, and you. In the first tiny fraction of a second, the universe expanded faster than the speed of light, a period scientists call inflation. In less than a heartbeat, the cosmos grew from subatomic size to something far larger. Then it began to cool. As it cooled, energy transformed into particles. Quarks formed, then protons and neutrons. A few minutes later, the first atomic nuclei appeared, mostly hydrogen, with a little helium. For hundreds of thousands of years, the universe remained a glowing fog of particles and light. It was bright, but opaque, like being inside a dense cloud. Then, about 380,000 years after the Big Bang, something remarkable happened. The universe cooled enough for electrons to join nuclei and form neutral atoms. Light was finally free to travel across space. That ancient light still exists today. We call it the cosmic microwave background, a faint afterglow of the beginning. If we could see it with our eyes, the entire sky would glow softly with the memory of creation. And in that early light, tiny imperfections, small variations in density, would eventually become everything. Gravity slowly pulled slightly denser regions together. Over millions of years, clouds of hydrogen collapsed. The first stars ignited. These early stars were enormous, bright, short-lived. Inside their cores, nuclear fusion created heavier elements: carbon, oxygen, iron, the building blocks of planets and life. When those stars died, they exploded in vast supernovae, scattering those elements into space. The universe was no longer just hydrogen and helium. It was becoming complex. It was becoming structured. Galaxies began to form, vast rotating islands of stars, bound together by gravity. Among them, one galaxy would eventually be called the Milky Way. And in one quiet spiral arm of that galaxy, billions of years later, a small yellow star would ignite. But we're not there yet. At this stage in cosmic history, the universe was still very young, only a few 100 million years old. Compared to today, it was like a newborn. Which raises our question again. If the universe is 13.8 billion years old now, is that young? Or is it already middle-aged? To answer that, we need to understand how long the universe is expected to last. And that story stretches far beyond what most of us can easily imagine. If this journey through the early universe is helping you relax, consider leaving a quiet comment below about where you're listening from. It's always beautiful to see how many places on Earth are connected by the same sky. Now let's move forward. As hundreds of millions of years passed, galaxies continued forming across the expanding cosmos. Stars were being born in vast clouds of gas. Some lived only a few million years before exploding. Others would shine steadily for billions of years. About 9 billion years after the Big Bang, roughly 4.6 billion years ago, our Sun formed. It was not among the first generation of stars. It was born from the recycled remains of earlier ones, which means the atoms in your body, the carbon in your cells, the oxygen you breathe, were forged in ancient stars that died long before the Earth existed. You are, quite literally, made of stardust. Around the young sun, a disk of gas and dust slowly clumped together. Collisions formed larger bodies. Planets emerged. One of them, the third from the sun, developed liquid water on its surface. Over time, chemistry became biology, and biology became awareness. For most of cosmic history, there were no observers. No eyes to see galaxies. No minds to wonder about beginnings or endings. Then, at least on this one small planet, the universe became conscious of itself. But here's something important to remember. Right now, stars are still forming. The universe is still active, still dynamic, still bright. In fact, star formation peaked billions of years ago and has been slowly declining ever since. The cosmos today is calmer than it once was, but far from empty. There are still trillions of stars shining across billions of galaxies. And yet, when astronomers look into the future, they see a slow change unfolding. Galaxies are moving apart from one another, not because they are traveling through space away from each other, but because space itself continues to expand, and that expansion is accelerating. Driven by something we call dark energy, the universe is not just expanding, it's expanding faster over time. If this continues, distant galaxies will eventually drift beyond our observable horizon. Future civilizations, if they exist, may see a much darker sky than we do. So where does that place us? Let's think in simple terms. The universe is 13.8 billion years old, but according to current models, it may continue existing for trillions, or even far longer. Compared to a potential lifespan measured in trillions of years, we are extremely early. If the universe's life were a 24-hour day, we might still be in the first few minutes after midnight. But there's another perspective. Stars like our sun have finite lifetimes. In about 5 billion years, the sun will expand into a red giant, transforming the inner solar system. Earth, as we know it, will not survive forever. So on a planetary scale, we might feel late. On a stellar scale, we are somewhere in the middle. On a cosmic scale, we are astonishingly early. The universe still has most of its story ahead of it, and that realization can feel both humbling and comforting. There is so much time left in the cosmic clock, so much silence still waiting to unfold. Now, in the next chapter, we'll move beyond the present era of stars and explore what happens when the lights of the universe slowly begin to fade. Let your breathing slow again. There is no rush here, only time. Vast, patient time. Right now, the universe is in what scientists often call the stelliferous era, the age of stars. This is the era where galaxies shine, stars are born, and light still fills the cosmos. But this era will not last forever. Star formation is already slowing down. Billions of years ago, galaxies were far more active. Giant clouds of gas collapsed frequently, igniting new stars in brilliant bursts of light. The night sky, if seen from a young galaxy long ago, would have been more crowded, more luminous, more alive. Today, much of the raw gas needed to form stars has already been used. Every new star consumes a portion of the universe's remaining fuel. And slowly, very slowly, the cosmos is becoming quieter. In about 5 billion years, our sun will reach the end of its stable life. It will expand into a red giant, growing large enough to engulf or scorch the inner planets. Eventually, it will shed its outer layers and leave behind a dense white dwarf, a small, fading stellar ember. But the Sun is only one star among hundreds of billions in the Milky Way alone. Across the universe, stars of different sizes live very different lifetimes. Massive stars burn quickly and die young. Smaller stars, like red dwarfs, can burn for trillions of years, far longer than the current age of the universe. This means that even after galaxies stop forming new stars, many existing stars will continue shining for an unimaginably long time. Picture a cosmic city where the streetlights are slowly turning off one by one. Not suddenly, not dramatically, but gently and gradually. That is the future of the universe's light. Over the next trillion years, star formation will decline further. Galaxies will age. Their bright blue stars will die, leaving behind longer-lived red stars and stellar remnants. White dwarfs, neutron stars, black holes. The sky, if anyone is there to see it, will look dimmer. But it will not yet be dark. Not completely. Because the smallest stars, the quiet, steady red dwarfs, will continue glowing long after larger stars have vanished. From a cosmic perspective, the present era is still vibrant, still full of energy, still filled with light. Which suggests something remarkable. We are not living at the end of the universe's story. We are living during one of its brightest chapters. If this calm journey through cosmic time is helping you unwind, consider subscribing and saving this video to your playlist for future nights. Now let's move even further forward, far beyond the lifetime of our Sun, far beyond the lifetime of most stars, into a time almost impossible to imagine. Trillions of years from now, the universe will look very different. By this point, almost all star formation will have stopped. The great stellar nurseries, the clouds of gas that once gave birth to countless stars, will be nearly exhausted. Galaxies will no longer shine with the same youthful brilliance they once had. Instead, they will be filled mostly with aging stars and stellar remnants. Red dwarfs, the longest living stars in the universe, will slowly burn their fuel over trillions of years. These stars are small, efficient, and incredibly patient. While massive stars blaze and vanish quickly, red dwarfs glow softly for time spans so long they dwarf our current cosmic age. Eventually, even these last stars will begin to fade. One by one, silently, the universe will enter a new era, sometimes called the degenerate era. In this distant future, most luminous stars will be gone. What remains will be the remnants of ancient stellar lives, white dwarfs cooling into black dwarfs, neutron stars drifting through space, and black holes quietly dominating the gravitational landscape. Galaxies themselves will also change. Because of cosmic expansion, distant galaxies are already moving away from us faster and faster. In tens of billions of years, they will move beyond the observable horizon. Their light will no longer reach any observer within our local cosmic region. To future civilizations, if they exist, the universe may appear empty. They might see only their own galaxy, or what remains of it, surrounded by deep, endless darkness. No visible evidence of the Big Bang, no distant galaxies, no cosmic background radiation easily detectable, just silence and darkness on the largest scales. And yet, even in this quiet universe, motion continues. Gravity still works, time still flows, particles still exist. The story does not end suddenly. It softens, it slows, it stretches. Now we continue, further, into a future so distant that even stars are no longer the main characters of the cosmos. After trillions upon trillions of years, the universe will be dominated by its most mysterious objects: black holes. These regions of space, formed from the collapse of massive stars or the centers of galaxies, are incredibly long-lived. While stars burn out and fade, black holes persist for incomprehensible lengths of time. At first, they will quietly orbit within dark galaxies filled with stellar remnants. But over even longer periods, gravitational interactions will slowly eject many objects from galaxies. Some remnants will drift into intergalactic space. Others will spiral into black holes. Galaxies themselves will gradually dissolve. Not violently, but gently, through countless gravitational encounters over unimaginable timescales. Eventually, the universe may become a sparse landscape of isolated black holes, wandering particles, and faint radiation. And even black holes are not eternal. According to current physics, black holes slowly lose energy through a process known as Hawking radiation. This means that, given enough time, even the largest black holes will evaporate. But enough time here means numbers so vast, they almost lose meaning. A supermassive black hole could take longer than a googol years, a number far greater than the age of the universe today, to fully evaporate. So while stars die relatively quickly on cosmic scales, black holes linger like the last quiet guardians of the universe's structure. Their evaporation will be slow, silent, and incredibly patient. Now we move to the final, most distant chapter, a chapter of near-complete stillness. Imagine the universe after an almost unimaginable amount of time has passed. No shining stars, no bright galaxies, no new light being created. Only the faint afterglow of ancient processes. As black holes eventually evaporate, the universe will become increasingly simple, mostly low-energy particles, radiation, and vast empty space expanding endlessly. This possible future is often described as the heat death of the universe. Not a fiery ending, not an explosion, but a gradual fading into maximum entropy, a state where energy is evenly spread and no large-scale structures can easily form. No stars to ignite, no galaxies to grow, no complex systems fueled by usable energy, just an ever-expanding cosmos growing colder and quieter with time. And yet, even this is not a sudden ending. It is more like a long exhale, a gentle drifting apart of everything that once existed. The universe does not rush toward its end, it relaxes into it. Which brings us back to our original question: are we in the middle of the universe's story, or near its end? Based on everything we understand today, we are astonishingly early. The universe is about 13.8 billion years old. But its potential future could last trillions, quadrillions, or even far longer. Compared to that scale, the present moment is not the final chapter, not even close. We may be living in the early luminous era, a rare time when stars shine brightly, galaxies are visible, and the cosmos is still rich with structure and light. A brief window of cosmic brightness, a golden age of visibility. If this perspective makes you feel a sense of wonder, you can support the channel by subscribing and sharing this video with someone who loves space and relaxing science content. Now let's slowly bring this journey to a peaceful close. Take one last slow breath, and let your thoughts drift as wide as the cosmos itself. When we look at the full timeline of the universe from the Big Bang to the far, silent future, something beautiful becomes clear. We are not at the end. We are not even in the late stages. We are living during a vibrant, luminous chapter of cosmic history. Stars still shine. Galaxies still glow. New discoveries are still being made. And for a brief moment, in the vast lifetime of the universe, consciousness has emerged to observe it all. The atoms in your body were forged in ancient stars. The light you see in the night sky began its journey millions or billions of years ago. And the universe around you is still unfolding its story, second by second. Long after humanity is gone, long after the sun fades, long after the last stars dim, the universe will continue, expanding, cooling, quietly existing. And yet, right now, in this present cosmic moment, the universe is alive with light and structure, which makes this era extraordinarily special, not because it is the end, but because it is one of the few times when the universe can be seen, understood, and wondered about. So if you ever feel small beneath the night sky, remember this: You are not late in the story of the universe. You are here near the beginning of its long, unfolding timeline, a calm witness to a vast cosmic dawn. Now, as you rest, imagine the stars slowly drifting across the sky, galaxies moving gently through expanding space, and time itself flowing peacefully forward. The universe is not rushing, and neither do you have to. Thank you for taking this quiet journey through the full timeline of the cosmos. If you'd like more calm space stories to fall asleep to, remember to subscribe and turn on notifications for future relaxing astronomy videos. And now you can simply close your eyes. The universe will keep expanding, softly, silently, into the endless night.